Welcome to the Slop Farm. Enjoy the video.
You begin by verifying the model assumptions that make the F distribution appropriate: independence, roughly normal errors, and similar variances across groups. Next, compute the sum of squares between and within groups and record degrees of freedom for each source. Once done, form the mean squares by dividing sums of squares by their degrees of freedom. These numeric steps produce the numerator ms and denominator ms. Make sure to label which ms is which before computing the F ratio. Now compute the F statistic by dividing the numerator mean square by the denominator mean square. This yields F with df1 and df2. Then obtain a p-value from the FEDF1, df2 distribution using software or tables to judge significance. Interpret magnitude and practical importance, not just p. Report effect size like eta squared. Once you have results, examine residual plots and perform tests, such as levying to confirm assumptions, and consider transformations if diagnostics flag problems. To finish, present the F statistic with its degrees of freedom, the p-value, and an effect size estimate. Add confidence intervals for means or contrasts when feasible. If the homoscedasticity assumption fails, switch to Welch's F or use rank-based tests such as Kruskal-Wallis. These reduce bias. And if sample sizes are small, apply permutation testing or bootstrap confidence intervals to improve inference. If things still go wrong, recheck coding errors in sums of squares and confirm group labels were assigned correctly.
Thanks for watching. Consider subscribing if we helped you today.